There we go. Alright, so we got, we have a graph. 4, that'd be 1, 2, 3, 4, right? 3, that'd be 1, 2, 3, okay? So we're in the first quadrant. You're going to have to know quadrants. 1, 2, 3, 4. Because with polar coordinates, we deal with quadrants a lot. What quadrant are you in, right? So we're in the first quadrant. Okay? The other thing is, what's the angle? So we want to kind of think, which triangle do you want to deal with? Do you want to deal with this triangle or this one? I mean, it really doesn't matter. Right? They're just inverses of each other. And what's nice is that the height of this triangle is 3. The length of this triangle is 4. And I chose this triangle because it's a 3, 4, 5 triangle. What? Okay? In other words, if I want to find this side, it's going to be a squared, which is 3 squared, plus b squared, which is 4 squared, equals c squared. Right? And that's 9 plus 16, or 25, equals c squared. And when you square root both sides, what do you get? 5 equals c. Well, we also get negative 5, but can we have a negative direction? Well, we can have negative vectors, but we'll talk about that later. Okay, so we have distance can't be 5, but negative 5. So it has to be 5, right? Okay? Just like in our logs, remember you couldn't take a log of a negative number? The square root of 25, c is equal to negative 5 and 5. But just like in the logs, this isn't possible in a distance. You can't have negative distance unless you're talking about a vector. And that'll come later. So, it's 5. Now, we want to find theta. We want to find so, ka, toa, right? So the sine theta is equal to opposite over hypotenuse. The cosine of theta is equal to the adjacent over the hypotenuse. The tangent of theta is equal to opposite over adjacent. Right? But it said all 6 trig functions. That means I also need cosecant of theta. Okay? Which is the inverse of sine, right? Co, no co. Co, no co. I know cosecant and secant go with these guys because cotangent goes with tangent, right? And we know that they're inverses, so that means this is A over O. That means this is H over O. So we got cosecant is a ho, and cotangent is a ow, right? Ho, ow. And then, what's secant? So I'm going to erase this little 3 here. What's secant? It's a ha, 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 ha. What? Never mind. So, oh wow. Never mind. Okay, so this is as much jokes as I got. Alright, so we're going to go, we have to know what's opposite, what's adjacent, all that stuff, right? So we're going to look at theta. We're going to go opposite of theta is 3. So that's my OPP. Right? Now, what about what's adjacent? Remember, the adjacent goes from, it's adjacent to both the theta theta and the right angle. So this bottom one is the adjacent, right? And hypotenuse is always across from the right angle.
5.
So that's 5. So it's pretty easy. 5 is hypotenuse, right? O is 3. A is 4. H is 5. O is 3. A is 4. Pretty simple, right? And then all we do over here is flip them. 5 over 3. 5 over 4. 4 over 3. That's it. Those are your 6 trig functions. It's really, really, really easy. Will it always be this easy?
No.
Of course not, because they're going to give you square roots, right? So you're going to have to learn to deal with square roots. But in essence, it's the same. Just treat them the same. It's just H-O-H. So, ka, toa, cosecant to ho, secant to ha, and cotangent to ow. Kind of like cow. Ow. Right? Who studies tau? Come on. Nobody likes Chinese lore? No? No Chinese lore nerds in here? No? Darn. No Buddhists? No? No Buddhists?
I'm like, where's that?
Alright. We're good.